is our test?
10.
I almost broke the test. So then I checked the video. It's the video which showed me that it is on 10.
We will still do something.
After long argument, what?
We will still do something.
You will still do something. Just because you did an experiment of it, now you are very excited that you will do it. Eh? So where are the others? I want to start on time. Because give you allowance, and this allowance time you should take it seriously. Anyone of you done a robot? Yeah, even the practical, doing a robot. It would have been nicer if you could program it yourself. And then make your desired program, explain what you have, what you are trying to, an activity you want it to do. Then you download it to the brick, and then you run it and it works. Then you feel you have done something amazing. But nevertheless, the beginning is not bad.
When you are still building it, you'll be inspired. You are building something
Sure,
that you are seeing.
it's almost, because the other bit is, if you wanted to build your home, during those days of challenges, secondary school robotics challenge, kids would make amazing robots. There is one of from the north, they built one which can mark the football pitch, and there are girls from Gayaza made one which becomes a forklift, one which goes, picks the things, puts them, takes them to shelves.
But I saw for this one, for this line follower, you can even mark the pitch. Because before you mark everything over a road or a pitch, you have to first put some these lines.
Yeah,
some marks.
yes, it can do that.
Reading cross.
What?
So you see, can read cross.
Can do what? Yeah, sure. It can spray, it can... I didn't, by that time I didn't have a laptop here, but I'd showed you those videos if you were here the first time of precision agriculture. Some videos of a sprayer which has antennas just to make sure that at a given point the nozzles keep going off. Okay, I'll prepare some stuff so that this group at least I showed them why they are doing it. The problem is if you want to do all this, you put in too much time like me. And if you don't have the time, then you just do what is official and that's it. But I'll do what it is good who will pay me. I have no content. Okay, now I'm starting because we ended on, we had started on the capacitance being the same as epsilon naught, epsilon r, n over d, and we had tried to look at these different variables, and the variables were the electric displacement, is it the dielectric constant? So dielectric constant. Then we have looked at if we can vary the separation, lead separation. Then we had the area. I don't know whether the signal here is still okay. Everyone these days sings about AI, so I made for you an AI video about electronics and instrumentation. And I put it on the course materials as well as, well, it's on YouTube, but I put it on course materials. It brings out the picture where all this, where the course content, and the net is okay. Once you log in on my names, it should be fine. You should be able to access stuff. And I was lucky that the people they put in there at least look almost like you. It's embarrassing to make a video and then everyone is white and you are giving it for, it's like meant for your students, they are all black. You can see how you feel. When do you feel whites are different? Yeah. It's genuine. How different are they? See apples, eh? There are apples which are green, apples which are orange, which are red. Is it red or purple? Or pink. And then there are those which are pale green. But the moment you peel off the cover, the taste is the same. However, you completed the can't be the same. However, but for example, racism. Sometimes I don't blame anyone to effect racism. Here, the way people from my place look like when they meet people. Do I have any person in my class who comes from the north?
Yes.
Yes. We are looking for, I'm trying to explain the dilemma of racism. People from the West who are, these days it is hard to know whether someone is from the West or from where, because these women have learned how to make themselves fair. So those days you would meet without lady and you just short wave. Short wave, you start your language. Nowadays you have to first inquire, because they have, I don't know how they do it, they have learned how to be fair. So, but the point is that when doing some baganda from Masaka. I don't know whether it is because of the sun or whatever. There are some who are dark, like this one here. So you feel like this guy is really different from you who is brown. That's why women are now becoming pale. So how do you blame the guy who is typically white? It's like a white pepper. They feel different. If you feel different at the local level. When I was in Norway, I felt like I was blue. Even the kids in the supermarket would look at me like this, as if I'm like some animal. And it was okay. You can't blame them. People whom I gave 30 minutes, I'm going to remove them.
For sure, please minutes.
I gave you 30 minutes, and now 10 minutes left.
I see that around 30 minutes are still there, others come home here.
Should I? How about if I remove the 30 minutes I allowed you, then I start at 4? Maybe there you become late officially. When you grow and you become like me, you know that time is money. Depending?
Yes.
How? Depending on what?
As a professionalist, they will tell you that a lot of time is money.
Little time is not money.
Yes.
Then you will not be professional.
Those ones are not professional.
A professional does little work for a lot of money. It's donkeys which do a lot of work for little money. There is, since you don't know engineers, there is an engineer for boats whom they call ships. So they called him to work on the ship. So it had gotten stuck. He came and looked at it, moved around, kept checking. Then when he had gotten the problem, he got his toolbox. It had a small hammer. There are these small hammers, they look like this. It's sharp here, then it's like almost like, is it the trapezium? Like this, and then the handle is there. Very tiny. So he got it and hammered somewhere like this. And then he told the captain to go and start the engine. And the engine started. So he said, I need $2,000. Hey, the adjutant, you just hammered there. And you need $2,000. He laughed it off. He said, okay, no problem. I just hammered there. But the time I spent looking for where to hammer is the reason I'm judging you. To find out that this is where the problem is. Maybe it was not even needing hammering. But those of you who have come later, I've added the video on top of the video lectures for this course, and AI generated. When I say, when you hear people saying AI, there's nothing much about AI. It's just, and I think Gemini, is it Gemini or what is the Google AI assistant they are? Yeah? Yes, so if you go to Gemini, it can teach you how to do this. And you can make videos of whatever you want to watch. So when you go to Gemini, don't chat with Gemini. Just go there and say, make a short video or make a 10 minutes video about, for example, transducers. It will generate a video. Introduction, characters, so it will put it introduction, 2 minutes. Then explanation, then it picks photos and videos from everywhere. I don't know whether I tried to explain to you what AI means. AI is the same as formal education. For example, lawyers can fit to be called to be using AI because a lawyer must be having all his files there for citation of the case. So the difference between probably we and them is because for them they would read and know where, when they are arguing the case, they have arranged them, then they open, according to the case of the Makerere University against students, this and this was the precedent. Then if they fit it on the case they are working on. That's AI. Even when I give you an exam and you are busy cramming, whether cramming or recording, that's AI. You are trying to give in your head to look for whatever. So it will make for you a video, introduction, word, then afterwards it says end. Then you will copy this and you can go to another website which is called, I think, InVideo. InVideo, they allow you to put the text you open here. Then you paste it here. And then you tell it to generate a video. And then to look for photos. Everywhere, photos, small clips. And then give you a choice whether the person to narrate the video should be a girl or, okay, female or male. And then your video is done. And also you have a chance to go there and remove some of the photos and put what you want for that same period of the clip. And then you make a video. And then I see people hyping AI. Even last night after I had made this video, VOA also, the Street Talk Africa was also on AI. So I said, what kind of nonsense is this? So AI is not just, artificial intelligence is not any intelligence that is, even now I'm teaching you, I'm giving you artificial knowledge, artificial intelligence. When you are trying to do the test, you'll be recalling what I told you. That's AI. So when they used to talk about, we are in the fourth industrial revolution where we use robotics, AI. So I just look on, I'm like, okay, this is how you make it look complicated. When they talk about robotics, they don't know now for us, we play with them and do whatever we want. So now that a number of you are here, we stopped at looking at these variables. We had looked at the variable for area, no, separation. We had we finished that of area? I think I was supposed to go to area. Because I had just said that for separation, when we have this plate, and then if we can move the plate, at first we had a plate which is, not which is, but when we have a displacement, either making them squeeze, is it squeezed or closer or farther? Yeah. And this was the X, and then the other plate was here. And then we came up with the capacity due to the displacement being equal to the epsilon naught, then the area, and then we get, I think we adjusted it and said it should be D, plus or minus, depending on whether we are making the plates come closer or go farther. So B, we go to the area, and the area I try to explain. Maybe I will make a demonstration. I mean a demo. I don't know whose file this is, but I wish I could spoil it. I don't know if you could look at these files as circular, and can you manage that? Like make yourself in your mind assume that no, semicircular. You see them as being semicircular. So I have two semicircular files, one line on top of them, And assuming here we have a place like where they can turn easily. So I am having this as the one of the plates which is fixed, and then I have this one here which can move. As we are here, they are having maximum area because of both of them are on top of each other. Now if I adjust a bit, I will start going away from this area, so the area will start decreasing. So once I have made them look like this, then it means that there is no area at all between the two. But when you turn it and now the area is increasing slowly until when you have maximum area, when they are both on top of. I checked my radio in the weekend, but I didn't bring it to show you the tuning circuit. So since we are meeting on, well, this is the last lecture before the test. Okay. After the test, I'll be able to bring the thing so that you get an idea of what is going on. So variable area, I don't know whether I was using small or capital numbering. Was it small or capital? Small. I just want to be consistent. And so the variable area, the displacement x causes displacement x causes the overlap area to decrease. The overlap area to decrease. So I showed this for the one on the tuning circuit, but also if I had these two plates and I displace one plate, okay, I displace one plate like this. When I have reached here, how much area do I have? If these were two plates and I've slid this plate up to here, how much area do I have? 0. So once I put it back, I'll be getting capacitance increasing until when I've now reached on top of each other, I'll be having maximum capacitance, because now the area is maximum. So if we have plate A or the one of the plates like this, and then you displace the other plate by distance x, the separation is not bothered, then the area A will be equal to the original area minus the width times the x. This, if I may just make it 3-dimensional, if I make it 3-dimensional, this is the way it would look like. So you have this, and it comes like this. I'm just adding the other dimension. So we have this area here. If this is the width, this is the x here, and so previously, if it was area A, then we would now have area A minus this part which has gone off the space. I made this side probably looks long, a bit longer, but so this is the width. The W is the width, where W is the width, plate width, plate width. And this culminates into C being the same as epsilon naught, epsilon r. The area, we got a new area which is A minus omega x, and the separation is senses that you are moving the plates. And then where to apply it, it's up to you. Is your ingenuity is where you say I will apply this is up to you and your experience. You cannot apply something to where you don't know. Like you have never sat in a vehicle and then you say I can put this in a vehicle. How? You don't know. So we tend to innovate depending on the, first of all, innovation depends on the problems we are faced. The reason we are dumb as Africans, we don't have problems. You are walking around, you see jackfruit behind there, then you monitor it. When it starts doing, it has not been okay. Then you say, now it is fine, you eat. And that's it. Your day is done, or your month is done. You keep eating slowly, or looking for others. In Europe, or in the United States, if you have not worked, you don't eat. If you find people eating, they eat and even lick their lips. It used to happen here in Kampala. That you visit people in Kampala and then they give you food. For the first time we visited someone when I had just come in Kampala, and then we reached there, we sat, they ate, they finished. They said, that day. So I'm like, what the hell? How the hell can I visit people and then they just chew their food and then when they are done, then they start saying, that day, what the hell is that? That they have a budget, their budget was to eat their food, you are not in the budget. For us, we used to eat food and even they say, we are tired. So if you come, you eat like as if we had organized for you. So it was very strange. But because of the economy, this is a place where if you had bought 2 tomatoes, if somebody comes, then you are not on budget. You just have to chill until when they are finished, then they greet you. Then we can graphically, we can express it as we have this being C naught, and then we have CX, and then we have the L. What would the L equal to? In terms of the area and the width, see, in terms of the L is this one here, the length of the plate. And if they have an area A is equal to length times width. They can just say LW. So that means that the length would be this is the displacement X that we have. So this one, we should label it as the capacitance due to the displacement X. Knowing these basics, these variables that I am keeping on writing, these on W, the X displacement and the like, they give you an impression of, once you know how they are operating, then they guide you on how your instrument will work. Our role is to make an instrument. The reason we are looking at sensors, whatever, for example, a thermometer has a sensor, a heat sensor. So if it is a mercury barometer, the bulb here, down here, this bulb here would be having the mercury, so this is your sensor. So you cannot be looking for temperature of a malaria patient and then you push this one in the armpit and then you wait. You have to make sure your sensor is the one which is in the armpit. Then your sensor, you also have to know what is affecting my sensor. You cannot now just put it, someone is in a jacket, then you put on top of a jacket. You have to slide in to make sure that you get the actual body. Next is the dielectric. And in the morning, when I was trying to see how much we covered, I realized that this is the perfect. The one I was explaining doesn't really make. Okay, it makes sense, but it doesn't make it come out easy. This is the perfect one that you can make the plates, the door, this lock alone can be the capacitor. So you have the other time I was talking of even going the other side, that the plates go there. This alone can be the capacitor. So you have a plate this side and a plate this side. And then when you lock, there are locks which have double. I don't know whether there are those with triple, but then there are those when you push first, then they have a second one. So this I've done. This I've done with. You are from education or from home? From meeting. From CTO. So when we change the dielectric, okay, when the dielectric changes in 2 dimensions, we can draw it as this, whereby we have these 2 plates, and then we displace the dielectric in here. So if we displace the dielectric out, if we pushed it out, then we will be able to I still insist that there is no urgent call that is more than the knowledge you get in class. Because even if it is your dad or your mom, there's nothing urgent. You wouldn't do anything either. So if this is our dielectric, so the way I push, the way I turn the key to lock, then I displace that lock at the dielectric, it moves. Then it means that at that voltage, first of all, in order for your instrument, your sensor to work, if you can transform whatever sensitivity you are having in either DC voltage, DC current, then you'll be able to make it readable and be able to display it in one way or another. So if this, of course, this distance should be equal to this distance. If my eyes are okay. If I do this, should be up here. Otherwise, if it is to fit in. So if we displace this by x, here, this is x, the displacement is x, and the separation is still d, then the plates are of length L, and then if this area of permittivity, whatever, has an dielectric constant epsilon R1, and this one has epsilon R2, then we can find the total capacitance that results from this displacement. And the total capacitance, since we are having these 1 and 2, C, we will equal to C1 plus C2. And if it is equal to C1 plus C2, then it means that our C in the first place Which connection? Series or parallel? This is the problem. I shouldn't have written this when I read this. So these are in parallel connection. That's when you add them. But also the idea is that they are all connected to the same potential. That's what makes them parallel. So there are two capacitors now. One, because this one is useless. It is like this. Because there's nothing here, so this part of the dielectric is useless. So we have a capacitor with the free space here, and then we have a capacitor up to here, which is the dielectric field capacitor. And so C1 would be equal to epsilon naught, epsilon R1, and then A1 over the D is still the same. C2 would be equal to epsilon naught, epsilon R2, A2 over D. Then we can look for the A1 and A2. So A1 equals to how much? So I'm going to spoil the diagram again, like I did for the other one. So this is exactly like this. And then this one here is like this. And so I can do this here. And probably do this also here. And then this one here is like this. And so this is epsilon R1. And we just put some bit of this here to make sure that it goes like that. And so we have this one as the width. And because of this, this is our X here. And so we can now, so this other part here is this one here, is L minus X. So this is the lock which was protruding there. And whenever you protrude, when you lock, the protrusion takes place, capacitance changes. If somebody comes and fails to disengage the alarm and unlocks and changes the capacitance. Okay? Now today I looked at it and felt different. When I have come in and I don't know that this lock is engaged, there is an alarm here, I come, I find when it was like that, locked in the door there. So me I come and with my key, because I have duplicated it, or I could get a master key, I'm a robot. Me I come and I enter and then I walk there. Before I push, it's already making noise. Because the owner had engaged the what? The alarm. Which alarm was being enabled because of the change of the capacitance. It is locked. The capacitance is by these two. When you unlock it, then the capacitance changes to the one of the full direction. And then that voltage gets gets fed in the circuit and then starts making noise. And then that unit would be almost inside here without any body. So it's up to you. You can don't underestimate yourselves and say, what will I be doing making alarms? You can start small and become a rich man. You find you are the Mulwana. The late Mulwana started with these wooden combs. You get wood, make it in a shape, and get some chisels to start making the small, these small fingers to make, and these combs, when he took them to London, they were biodegradable. They were not associated with any disease, and that's how he started. Then got house this plastic, whatever company, and started making plastics, the ones of plastic. And he died the richest manufacturer. So don't underestimate yourselves. You start small now, you get in yoga, you get in yoga money, and you move on. Me, I'm very sure I will get too much money. Yes. I have one innovation I have got. I will never tell anybody. Until when I have made my product. When I make my product, I will invite you all for an evening and say I'm now done. And I can assure you this one is going to make me very rich.
Let me follow.
That's it. It is not connected to technology. I will be solving common person's problem. It's not. It's not like you do it. I want to make sure that it is modernized, and then I get the product to the market. Once it is on the market, I have already tested. It works, but I am still looking for how to make sure that I have no problems with these other, agencies. The moment I get that, I'm going to just sit home and money will come. Because the ingredient is easy for people to follow around. So I'm not telling everybody. No. Until when I've, even these companies which are whatever, I'll lie to them of the ingredient.
Baking powder.
You are tickling me today, I won't tell you.
That is a
So C1, sorry, A1 due to this, associated to this capacitance here, for this part here, would be the same as W. So A1 equal to WX, then A2 equals to still W, then the remaining of the length is L minus X. And this would imply that C1 equals to epsilon naught, epsilon R1 WX over, then and C2 would be equal to epsilon naught, epsilon R2, then we have A2, which is W in L minus X over. So total capacitance C, which is equal to C1 plus C2, a typical parallel connection, would be the same as epsilon naught, epsilon R1, WX over D. Then we add on epsilon naught, epsilon R2, W in L minus X over D. This would be the same as, the rest is algebraic. So this would be epsilon naught W over D in, this would be epsilon R1 X plus epsilon R2 in L minus X. Maybe we put these ones. Okay. Any more simplification we can do? So that means that we can now compare it with did we have time you can find out exactly what is, how everything is coming out. So C will be equal to epsilon naught W over D into epsilon R2L minus epsilon R2 minus epsilon R1 into X, or we say that C equals to C naught into epsilon R2 over epsilon R1 minus epsilon R2 over epsilon R1 minus 1 into X over L. Where C naught is the one without, so which is the same as epsilon naught, epsilon R1 A over B. And the A we are talking of is the whole area of the plates, which is the same as the W. I'm not going to do algebraic gymnastics for you. And we can plot this. Anyone having issues with the diagram? Because I'm going to chop it off. Do you feel I have made a mistake in that expression? C naught, epsilon naught, then omega, not omega, W over D, then E no, there is only the X remaining with epsilon R1, and then if you go to this other step, you can expand so that it becomes epsilon R2L here, then minus epsilon R2, this one here, X, then it would be plus, but once you put this one in here, the plus is made by this, X, so that gets finished. And then you put C naught. So C naught is epsilon naught, epsilon R1. Let me first be sure. C naught is the one which is was remaining here, empty. So the one which was empty, it was C1. But C naught is when you don't have a directory. So if it is when you don't have a directory, that means it will be epsilon naught, and then the epsilon R1 was for this empty space. That was the directory constant. So when you remove the directory, you still got that directory constant of air, of free space. So that's why we have this feature in here, because it was that part for where there is no directory. And then the area is now the area of the whole full plate area. Over the separation, we didn't do anything on the separation. And then graphically, we have our graph, and then this is the C naught, then we have this one. You have any problem? I hear from Mama. You ask if you have an issue. This is the length, displacement goes up when you have full length of the plates. And then at this point here, you have the epsilon R2 or epsilon R1 C naught. And this one here is epsilon R2 or epsilon R1 C naught. And this is epsilon R2, and which is when it is greater than epsilon R1. And here you have epsilon R2 being less than epsilon R1. So you don't have to say that why is it that it's the same ratio up and down. Here it is when the epsilon R2 is greater than epsilon R1. Here when it is less than epsilon R1. This is the origin. So we have now a slight idea of, for example, an example of the capacitor transducer as a transducer. We used it as a microphone. Now that we have now tried to see how each of these parameters, the separation, the area, and the separation, the area, and the permittivity, that is for the dielectric, how they can be used to find that, to make sure that we sense. The issue is about how we can sense. Those of you who have done the robot, we only used 2 sensors. 3, touch sensor. When the robot would be knocking something, it would be just making sure that the bumper pushes the touch sensor. And then the program says when the touch sensor is pushed, it should go backwards to a distance where when it is to turn, the bumper does not knock that obstacle again. Then the neck will look for where there is no obstacle, and then that's where it will turn and go. If it still finds there's an obstacle here, it will look for somewhere else until when. And probably I should get some boxes for the next groups so that we can put boxes here and make it the Explorer enter from here and see how it maneuvers to come out there. But you know the challenges. The batteries are low. You also want to go away.
And still improving the position.
Yes, even today I asked the technician, he says, they are still approving, the auditors are still approving the thing. So I'm lucky that the batteries I bought at least are showing some hope that even next group may work and finish. So imagine we could even do, I told you I built the whole thing and just stand once, just did like this. Then froze. Which one? This is C naught. This is the pardon? This is epsilon R2 of epsilon R1.
They are the same. And yet we say they don't want.
These are the same.
Yeah.
Yes, but at lower, at this bottom, this one here is less than this one. So it is lower, it is this way. And then at this point, the dielectric is more than, if the dielectric is more than the dielectric of the dielectric constant of the dielectric is more than that of, if it is more than that of the free space, remember this was free space, then you are, yes,
50.
Ghana.
As I'm trying to the graph, the expression like this.
Which expression are?
Which expression for capacitance? How is this going to do that?
We are having this should be capacitance, this should be Cx. Okay, the capacitance that we have and as how it varies as we displace the dielectric from start when it is fully inside and then start displacing it. That's your mathematics business. It is not my business. But this, sorry, I have not put this one. This is the capacitance due to the displacement. And then this is the displacement when you are trying to draw. Okay, so let's look at other commonly used capacitive sensors. And all of you, I think all of you have smartphones. Anyone without a smartphone?
Maybe
I can buy you one. Anyone without a smartphone?
Me.
I'm here.
Me.
Maybe.
Just because I said I can buy you a smartphone?
Yes.
Like BFT, I'm here.
Other commonly, yes, I don't have money, I just have a recharge. So how will I buy you the phone when I don't have the money? Other commonly used capacitive transducers or sensors. So we start with the pressure one, this one which we busy do. You see me pushing, then I put my my pattern. After putting my pattern, then I tap on the whichever thing I want to access. So it responds to the pressure. You can't just do like this and then it moves. You have to make sure that you put some bit of pressure, then you make it move around. Then you try to tap in order to go to wherever you are going. You tap, then you look for what you are doing. So that pressure bit, which is what we shall start with. And look at capacitive pressure sensor. Capacitive pressure sensor. But the world is unfair. In 2010, I bought Kindles. And the Kindle was like the best technology you can have. I still got one. I think these days it has lost its screen. Everything has become dark, but I will come probably with it next time just to show you. And this Kindle was just a few buttons here, then the screen which is black and white, no backlight, like the one we talked about when we were talking of the LCDs. No backlight, but they would sell you with some light which you can hook on, and the light, does like this. But it had like paper. When you'll be reading it, it's like you're reading a paper. With the forward, back, home, and some experimental music player, MP3 player. And if you are in a region where there is network for Amazon, you will get some books wirelessly on the Kindle. So it was like I was having the best technology. I kind of this also the thing. Now, in a few months, this guy of what was his name? The one of Apple, the one who died.
Steve.
Yeah, Steve Jobs, I think. Steve Jobs. The guy just goes on the podium and he announces, we now have an iPad. Now an iPad was, everything changed. My thing became like a toy. The iPad had, an iPad, a typical iPad. It's a tablet, it has a screen where you slide things, you even hold them like this, they become, you zoom in, you zoom out. And then music, videos, my thing became obsolete. But shortly, the Amazon people also produced a Kindle, which was nice. So I think I bought 2 generations of the tablet Kindles. They all died, now they are all dead. But I bought them. So the idea was, or the idea why I'm talking about that is, imagine how people are innovating. These ones had already, it was like it was the best of innovation for the kingdom. Now the iPad comes in. So when do they do these things? You whom I see lousing around, you are just there talking, that guy, that ball shouldn't have been. That's not your business. I can't have time to talk about football, so what? Politics I can, because it affects me. When someone screws up, you all die for nothing. So politics I talk a bit. But football, you find me arguing about how the corner couldn't go in. So what? I like to play. No, I dribble. If you want, we go to the pitch. None of you can stop my dribble. He doesn't believe me. It's okay. We can. On Saturday, you get a football. I show you. Since you guys are here, I have a function here. Saturday, you can organize. We can go at the back there. I bring all of you. Yes, I have videos when I'm dribbling people at home.
You are looking for a ninja.
Why you think I'm too soft that I break easily or what?
Can you people participate?
So this pressure, so it consists of one plate and then the other plate, which is a disc that a diaphragm that can easily respond to the pressure. I don't know when, because this one, it's not, well, it is pressure, but this is glass, you know. It's not that really when you hold that it is going backwards. So, I don't know. There are some, that's why I told you that this is juju, nicely packaged. And for us, we buy, we hold, we go around posing, but they are the ones who actually know the exact beat that they made. Otherwise, you just imagine you are doing like this, then you can slide things disappear this way. You don't even know where they have gone. And then whatever you want comes.
I think the whole screen is made of.
No, I like how you people want to show that you are smart. And you want to show that these things happen, but let me stop there until when my innovation is done. Then I will take all of you out. I am taking you out at the end of the course. But when the other one breaks through, I will invite each and every one on launch of my product. I make sure you eat and grow.
It is for eating. Oh.
The what? The product?
Yeah.
No, it is not for food. Why are you looking for out? You think I'm stupid that you just can make me tell you my product?
Baking powder. TWINAMASIKO baking powder.
No, I have nothing. I don't even know how things are baked. I've never baked anything.
You have a theory.
Yes, it is a theory. It comes from theory. It's a theory. It is not. It has nothing to do with the. So this, I've just put this valley here. So if we have this the separation of these plates, and then we have here. This should be the same level if you can draw it nicely in that form. So I will take this point, and then at this point where there is a so here, this part here we shall take it as like where it is fixed, and then also here have this part like where it is fixed. And so from here to this other part, we call it A. Then if this is R, and then we have this being is this other part, and if this is the pressure, this is the pressure which we are applying. And we have, if this is air between here, so epsilon r equals to 1. Let's write something about it so that we know what we are in. After, make sure you remind me to make sure these notes are up and running.
Yes.
The challenge I got, not the challenge, but the issue is that I made them, the scanning, because to look good, I made them photos, and I have to get these photos and eventually make them in PDF. Like the practical, if you look at the instructions I gave you, they look clear. You can't believe that it is a scan of the other manuals we were using in electronics. So, because I had to process them that way, photo, then to a Word document, then size, adjust. So, these are, so far, these notes, which are constituting of, these are 77 pages. Okay, 7, because it starts from almost 7. So 7 pages, I have to process all of them and then make it a PDF. But I've already put 2 books. The third one, I'm still looking for it, concerning this course, which are the reference books for the course. These are the Principles of Measurement Systems by Bentley John P. Then Prokis Gay and Saveli Mosul for the Communication Systems Engineering, that part of the communication system. And then the one I'm still hunting for is Transducers in Measurement and Control by Adam Hilden. No, by Sindham. And so when you have all the textbooks, then you wouldn't have anything to bother me with. So let's see what is going on. One plate is fixed, the lower one. One plate is fixed. Is a fixed mirror disc. Is a fixed mirror disc. The other is a flexible. The other is a flexible flat circular diaphragm. Flat circular diaphragm. Diaphragm is P or G? Both. How? Is it like this diaphragm or P? Eh?
It is P and G on M.
PG.
No, it is P diaphragm.
PH.
Then there is a G on between A and M.
There is a good between A and M.
I don't trust any one of you now. Since I have internet, let me Google. This never attended he never attended nursery. It's like me.
Say the next one.
It's nursery. Just because they were babysitting you, you thought it was nursery.
The next one, 2-1.
So it is diaphragm. Diaphragm. So there is a
For simple one, just store and he skipped the baby. I'm going to piece
the diaphragm clamped around clapped around, wrapped around, clapped around. You see, the freedom I have in my life is that I'm in front of you not because I'm a genius or special, but because I'm lucky
You are older than
that I got born, that because I got born before you, at least in this whole class no one can say I'm older than you. And then the first time I see a lady wanting to be old, she had put up the hand. Ladies always want to be, but maybe at your level now you are still wanting to show that you are mature enough. Now when I meet these women and say, "Jeva record judge," then she go younger dear. But when they are kids in secondary or primary, when you say you younger, they say, "Who tells you I'm young?" So it confuses me. When they are young, when ladies are young, they want to show that they are mature. When they are already off the hook, off the shelf, of there, and you want to give them their respect, now they are like, you think I'm your mother?
You see what I want.
They don't know what they want. So they clapped around its circumference. I'm only the one who has license to speak. For me, I have the license. You are not you're not an idol too. The diaphragm is an elastic sensing. The diaphragm is an elastic sensing element. Bend into a curve. Bend into a curve. The other curve there. Bend into a curve. Bend into a curve by applied pressure P. By applied pressure P. There is a P here. This P for this pressure. Maybe I should have said pressure P. The deflection Y, this Y here, the deflection Y, the deflection, should it be deflection or displacement? It can't be displacement, but the deflection or the depression, which one do we use?
Depression.
The deflection.
The bending.
Huh?
The bending.
The deflection Y at any radius R is given by freedom is going. So the deflection Y is given by Y equal to 3/16 in 1 minus nu squared over ET cubed in A squared minus R squared, both squared times the pressure P. This is from which, is it thermodynamics or properties of matter? Good. So I have no business going any further. So just to make sure that you still have a feeling of the diagram, I am going to say here A is the radius of the diaphragm. This A here is the radius of this disc, the disc diaphragm, so radius of the diaphragm. And then T is here. This T should have been here. This T, if you can draw this T here, T is the thickness of the diaphragm. T is this thickness here. So it is here. The T is the thickness of the diaphragm. And then E, since you said it is in the properties of matter, is the Young's modulus. And then is it R or which one is this symbol? How do we call it? There is an R, then there is, how do you call this one? What does gamma stand for in the properties of matter? Poisson's ratio. But this means that this one here, which I wrote wrongly here, this should have been, and since we have no radius, this one A is the radius, and then I'm looking for the, so this is the, this is not R. You said this is gamma. Yeah. And this is the capital gamma. No. Sorry. No, I know what. Let's first do test one. I know what to do. Since you don't want to tell me what I ask, so I know what I will do after the test. So the deformation of the diaphragm, is it deformation or we say this deflection or deformation? So it's up to you. Which one you find comfortable? So the deformation or deflection of the diaphragm, the deformation of the diaphragm reduces the average, reduces the average separation of the plates so when you reduce the average separation, what happens to the capacitance? Which increases the capacitance C. Now the increase in capacitance delta C increase in capacitance delta C, just to be sure of the diagram. From clear notes, so I don't give you, they call it what, chemical? Anyhow, so the increase in capacitance, delta C, the increase in capacitance, delta C, is given by delta C over C naught equaling to psi minus nu squared, then we have L to 4 P divided by 16 ED T cubed. Where am I getting? What did we have in the brackets? Where am I getting psi? This is 1. We didn't define what? We didn't define no. But you accepted, you told me that you knew these things from dynamics.
It is the
I mean, the what?
It's the element that told you.
Where? So where C naught equals to epsilon naught pi s cubed over the d. And this is the capacitance. The capacitance when you have not added any pressure at 0 pressure. Just check something. So we had, I think there is a challenge in the expression. The expression should be, the previous expression we had should be this one here. Should be the Poisson ratio. Yeah. Just like then in the bigger one, it should be 1 minus, instead of nu, it's the Poisson ratio. And then the other, this other one remains R squared. This one, which we wrote as y equal to 3 over 16 E nu. So it should be 1 minus Poisson ratio, then E T cubed E nu A squared minus this remains R squared, and then squared P. There is no square, you can't have these two squared here, then you have this one, according to this one here. And then we have the deformation, that one we have already. And is there any other symbol which is now not defined? Okay. Okay, so then we have the capacitance of 0 pressure. When there is 0 pressure, everything is, this one is tight like this. Like there is no, this depression is not there. Okay. So the variable separation displaced sensor is non-linear, and this is a disadvantage overcome by differential or push-pull displacement sensor. So
Is this by tube or a tube?
it is A, which is tubed. Actually, which is it is not true. This is A. This is radius of the diaphragm, so this should be squared. So this is the epsilon A over D.
So that epsilon over C means there is A power 4. A power 4, I think it is supposed to be A squared.
Wait a minute. I have to confirm. This is 16, okay? So if it is 16, why do you say it is A squared?
I thought that we are using that in the Y. I think that we are using the A squared in the Y.
I am using which one and why?
The A squared, the one with the thick.
Okay, this is the capacitance equals epsilon naught, then the area over D. That is this for C naught. Then for the change in capacitance over the C naught, we have this at the bottom. Well, I'll check. I have no time to suffer. B. The problem is you are supposed to use your properties of matters. As I've spent centuries without talking of the pardon? How what? Okay. Can we now get the sense of what is going on? The Y is the deformation, and it is being given by that. And so the issue is capacitance, which is equal to over D, which D is the original here, because after you deform it, the diaphragm here, and this is the fixed, this is the D. For original, for the C naught. For the C naught, when you have no pressure, this is the same as epsilon naught, then the area is pi A squared over. Now, the challenge is when you put pressure, the separation does not change uniformly. It's not like you have displaced so that's why I'm saying that from your properties of matter. So the deformation, this deformation is being given by 3 over 16, then this bit 1 minus cos 4 over ET cubed, and then we have the A squared. How do you get this in the first place? Since you are experts.
I don't remember seeing such an expression.
You don't remember seeing it? But you got something so close when you are looking at this when the ball is moving in oil and has reached terminal velocity. You did something of the sort. Yes.
What is the R? You say it here, we define the
R is this other, this one in the middle here, where you have maximum, like maximum deflection or deformation. This side here, we got the radius of the diaphragm, and then from here, from this on this other side, like if you were tapping the thing, from this side, this was the R. So I'm trying to see whether we can derive it together, but would that help me?
No.
It is wrong. Which one is wrong? The derivation I'll get will be wrong. Wrong.
You guys did it before.
That's the problem. You have a problem with R and L. So me, I had wrong. But for you, meant wrong. You have heard of this thing of you are lost. You are lost. No, I'm lost. Isn't it how you people say it? Yes, hello, you are lost. Then the other one said, I'm alone. This problem is a problem of calling that left and sleeping horse. Do you have that problem? Yes, I do.
What if in that expression of y, the square was there?
What if the square was here?
Now the down one has a, meaning the r was ignored. Maybe it's 0. That's why the a became 4 to the power 4.
Like you are saying that if, let's say, it was to be deformed uniformly,
Yes.
that the radius, the other part of R was equal to A. Or why are you saying that if it is 0? Why shouldn't it be 0?
Because we are having a power 4 here, and we don't know where it comes from. But there is a square, and then there is a square outside there.
Okay. What would be the change in the capacitance once you have applied pressure? That's where I want us to start from. We have applied pressure. This has changed. The Y here is the deformation, and Y is being given by that. But we want to get the DC, the delta C, which is the change in capacitance. And we said change in capacitance, so why don't we have anywhere, we divided by C naught, so if we didn't divide by C naught, that means we would be having on top here, we would be having D, okay, and then over epsilon naught pi A squared, and then in with the rest of the expression. So this would be 1 minus squared A4 over 16 E D T cubed. And of course the D can go, but we don't have anything to do with the 3, and then we don't have the P. The P is there. The P is okay, and so I'm looking at so I will not waste time here. I'm sorry. We will do it on your own. And if you don't, then by the time I come back, I should have in other words, much as we should be able to figure it out, this is to show you how the capacitance will be varied. So only that we need to get the actual values. But for now, allow me to move on, and then we shall be able to get the algebraic gymnastics. B, yes?
For these capacity pressure sensors, and do they all have the same kind of material made or
You see, like different companies will use different materials. So you would say, do electric vehicles have the same material, like batteries, which are the same, or motors? So you find Elon Musk finding his special material to use. And some of them even keep it secret. Before Mulwana died, these Exile or something, the way they called the UBL batteries were very good. Nowadays, you buy a UBL battery, after some time, it kaput. So he knew the formula. Just like you see Coca-Cola. There's one guy who knows the formula of Coca-Cola, whether he puts in cocaine or whatever. You can't find the formula. They know what they put there that makes you want to take Coca-Cola all the time. And this one particular guy, I think they imprisoned him somewhere also, not to go anywhere abroad. That's why I'm saying that with my thing I'm going to make, I will never tell anybody.
What if you die?
I die with it. Why do I care about you?
What if I innovate something like that?
I die with my... No, this one, I'm telling you people, this one is mine alone. When you see, I will launch the product, don't worry. I'll launch the product. I'll make sure that the media is there, then I'll launch it, then I'll start milking money.
The good thing is that they will wait for you to finish yours and they copy.
This one, even the people who are so close to me, I'll never tell them the source. Because I am saying close, when they are son or daughter or wife or whatever, or brother, whatever, nothing.
That's the problem with Africa. You don't want to share.
No, this one, it has been there somewhere, I ignored it. Me, I got it. It's not like if you got something from somebody or whatever. This one is God-given. And so I cannot waste my opportunity.
The problem is that they start telling us that it's from South Africa.
Yes, it doesn't matter whether it comes from South America or whatever. As long as it works. And it works already. The only thing I'm left with is to make sure it is official. So I know someone here knows how to drive. Like I know how to drive on the corner at 120 kilometers per hour. But I'll never tell anybody how. I've always been nice. I've been nice before, telling people how things work. And these people just copy my idea, they use it, and they look at me as trash. So now I've also started being mean. So when I'm entering the road, like especially the northern bypass, people pass me. I keep quiet. So I wait them on corners. Me, I just go like a rally driver. They see me pass. I see them just. I pass them, all of them, I go. So I'll never tell anyone how I do it. That one I'll never tell anybody. I've done a lot of things and told people how things are done. But now I'm tired. For example, the rain. I told you when I was giving you moon viewing that 2 days to the, yesterday was a new moon. 2 days to the new moon, it will rain. 2 days to quarter, either first or last, it will rain. 2 days to the full moon, it will rain. I don't have a weather forecast. Today I came very early because I wanted to be here before the rain starts. And I was here earlier than the rain because I knew it was going to rain.
The rain is starting there.
Sorry, so please, let's check this expression. I don't want to go into the said properties of matter. I don't want to go into Young's modulus. So we look at the differential capacitive displacement cells. Capacitive displacement cells. So this is fair, okay? Because we are just displacing the plates. So if we have the plates, just look at this one maybe more clear than this one, maybe it doesn't. So if I have the plate, plate P2, and then plate P1, and then I have some other plate AB, and then if the distance between these two is D, and also here is D, and then at some point you displace this other plate through a distance X. What is it? This would be the what? You are correcting me. How did you see it wrong? Because it's far away. You are correcting which one? The other one or this one?
Yeah.
That one was dosing, so. So this is plate M. This one here, I don't know, maybe I should label here, M. Just to make sure I don't mix up things here. So I just want to be sure that, yeah. So we have two plates. We have this plate here, and then a middle plate, which can be displaced up and down. So the atoms are static, so whenever you move this plate up or down, of course the capacitance in the middle will be able to change. And that will depend on which example can I use for where you can have two plates and when you move. It's not easy, like this one of the lock here. If you don't envision it the way it should be, then you can't show exactly how it works. So just because I'm handled with locks, and so I'm just looking at an example of how that displacement would work. Well, I already talked about something to do with, for example, a weighing bridge, but the weighing bridge now would be if one of the plates, the upper one is the one moving, but this one is the one in the middle. So which scenario would you have a plate in the middle of plates changing, okay, that capacitance being to be sensed? What would be such an arrangement? What would be such an arrangement that would give us such? An arrangement of having two plates, and then you have a plate in the middle which is changing.
For us in geophysics, when we are measuring gravity, we have devices called gravimeters. So when the gravity changes,
what is gravity?
Gravity changes the value of
What
gravity.
is gravity? What are you first explain, because you are saying if gravity changes, so I don't understand.
Okay, the earth bounces at the equator and it flattens at the poles. So gravity
Flattens at the poles?
Yes, it tends to flatten at the poles, the north and the south.
Okay.
So when we keep changing, maybe latitude, or even the area, the value, okay, the gravity itself here might be greater than in another place. So we have a device.
So what changes gravity? I thought it is about 9
There are factors, elevation, latitude.
So the higher you go, the gravity goes down?
Yes, something like that.
So why are people from Kasese very short? And then the one from
I'm saying the device. The device is
Because me, I'm looking at your device. Where do you install it?
the device. You just place it in an area. Then it measures the gravity. There is a plate in the middle. There is a plate in the middle of two capacitor plates.
Okay.
Then
So, but how does now this plate get affected to this place in between the other plates?
The gravity affects it.
So it is hanging on a spring.
Yes, it is on a spring.
So the spring pulls it, and then it
pulls it down.
you detect that this place is having this.
Yes.
Okay. Any other further explanation you want from me? Of an example, give an example. Wait. Do you need any further explanation other than that which Fred has given?
I can meet him out of
The truth of the matter is that I like this guy for his comfort with the course. You know, liking what you are doing. Not people who seem to be like they were forced to do the course. So, yes, what? So, may I tell the truth? Normally, I don't need to. So, he said, I don't know the construction, but this plate here can be affected by gravity. So that change in capacitance gets registered on the meter, and then you said it is called
It's
what?
called a gravimeter. Even these guys studied geophysics last service.
But they didn't understand.
Yeah, there was a machine when we measure the earthquakes. When an earthquake comes, that thing does like this. There is a gravimeter and that one. For seismic waves.
So which is which?
This guy,
Earthquake or gravity?
we use them in both.
To measure the maximum displacement of that plate, and when you are measuring the magnitude of the earthquake on Earth's surface. That's when you consider when Earth is vibrating on a spring, it must be taking the maximum magnitude, the maximum level from the top to the ground. When you use that amplitude, this will determine the magnitude of the earthquake that passed.
What are the units of the earthquake?
If it is magnitude, then it has magnitude.
But now we have this.
What are the units when you are writing that? When you say it is 6.01? Because they say it is strong, an earthquake of 6 point something, 6.0 something. What are the units of an earthquake? It doesn't have what? It doesn't have you just say 6.01. Okay, good enough. At least you have helped me to get an example of such a scenario. So now I move on. Plate M, which now the one which is swinging in the middle, is movable between two fixed. Is movable between two fixed. I didn't do geophysics. If I had done geophysics, I would be in petroleum. Because when I was teaching the electricity and magnetism, the petroleum students, I trained in petroleum technology. I was the one who made sure their lab was installed with licenses. If I had geophysics, I would have disappeared. I would be now either in Shumbaje or whatever. But I don't like going into things that I'm not comfortable with. I don't know how to be I don't like being a crook.
You are like plate.
So plate M is movable between two fixed plates P1, between two fixed plates P1 and P2. Now it flows, since you have an example, it flows. And it is an instrument. This course is electronics and how to use the electronics in instruments to get measurements.
Yes.
And that is a typical good experiment, a good instrument which is using electronics to do measurements of something else, a physical stimulus, like the earthquake. Now, effects the displacement, this displacement of the plate M. Effects is the displacement of M. Is the displacement of M. From the center. From the center line AB. So if this is our center, that's why we said if this is 2D, this is DD. So if X is the displacement for our M moves through from the center line, which is AB, then the capacitance MP1, the capacitance is MP1 and MP2 are okay between the capacitance between the plate M and plate 1 and between plate M and plate 2, these capacitances are C1 would be C1, let's take C1 for this plate, M plate 1, so this would be D minus X, and then the rest are so this would be epsilon R A over D minus X. C2 would be equal to epsilon R A. It has increased from D to D plus X. So this would be over D plus X. So these two are in what? Series or parallel? Now that I haven't done any expression, these two, when you have these two capacitors like this, are they in series or in parallel? The other ones were in what? The other one which we finished was you have this, we had a directory here, and we had C1 here and C2 in here. And we said that these ones are in parallel. C1 was parallel to C2. So these ones are in what? Yes, P1 and P2 are the plates, are the electrodes.
So the light ones are in parallel. In series.
So C1 and C2 are incorporated in an AC deflection bridge. Is it in or with? An AC deflection bridge. So you integrate it with the bridge. Bridge is, I think, DG. English is not my mother. Is that how they say it? However, I got a D at primary. At primary. Everyone gets a D1 at primary. From the village I was.
See the 100% sit down here.
So the diffraction V naught. The diffraction V naught is given by, so we first, so we integrate this into the diffraction bridge, diffraction bridge. The bridge is, we have V naught here, which we say it is an AC. And then it goes to the capacitors this side. And then we have this other side here. And then the other side we have the resistors. And this one is a resistor. I'm trying to make sure that I cover as much as possible for test one. Huh? It's too late. It's too late. I can't cover much. You are too bold, eh? This is R4, R3, C1, sorry, C2, C1, which have been integrated. And then we have the V naught here. V naught equals to, this is electrical magnetism, so it's none of my business here, plus R4 minus C1 over C1 plus C2, and then this is V naught, and this can't be V naught, this is supply voltage. Yes. So this would be in Vs in order to get V naught. Or can we arrange it as V naught equal to C1 over C1 plus C2 minus R4 over R3 plus R4 Vs. There's a point where I wanted to reach before I stop, and yeah, let me first check the time.
Yeah, okay.
2 minutes. I would wish if we had finished the parts of sensors, so that after the test we are dealing with the communication system, but no problem. We are supposed to end at what time? 6:30. You came 10 minutes late. And you think you will just cheat me like that? Let those who came, let's stay. And then those who came, no problem. If you feel when you
When it finishes 4:30, we start.
those who then
Those who come in, we will have to finish 6:30 or 6:30.
then they remain.
Suppose we are doing 4:30.
Then I am teaching new things when you have gone.
No.
Teach what they missed.
That's we go.
I just like the way you are twisting everything now. It's like so these all are just minor. I think you did also this bridge in finding the Boltzmann constant. in thermodynamics. Making R3 equal to R4 and equal to some value R, and substituting for C1 and C2 yields or gives V naught equal to 1/2 minus C1 over C1 plus C2 in Vs. And the C1 plus C2 is the same as epsilon naught, epsilon Ra in 1 over d plus x plus 1 over d minus x. And so implying that C1 plus C2 will be equal to epsilon naught, epsilon Ra 2d over d squared. D plus x into d minus x becomes a difference of 2 squares. So this would imply that C1 over C1 plus C2 was equal to that. So C1 over C1 plus C2 would be equal to, would reduce to epsilon naught, epsilon Ra over d minus x. Then we will reciprocate that one. The reciprocal will be d squared minus x squared over the numerator is epsilon naught, epsilon Ra times 2d. And this would be the same as this would go, epsilon Ra would go, and then 1 of the d minus x would go, you remain with d plus x, and down will remain with 2d. And thus, the potential V naught will be the same as a half minus d plus x over 2d in Vs. And V naught will be equal to d over 2d minus d plus x over 2d in Vs. Denominator is 2d. We add the top, these go. So this can be written as minus Vs over 2d, and we put out what is making it value, which is the displacement x. And so therefore, the potential, the voltage that can lead to a reading is the same as minus, is equal to minus Vs, the supply voltage, over the twice the separation of the plates. Then the relationship between V naught and x between V and x the relationship between V naught and x is linear. Is linear and very important. And source frequency. Of the source frequency. I don't have time, but I just want to introduce you. I will ask the paper will end here. But before we go, I just want you to understand that the next one is a capacitive level sensor. So for example, if you have a tank, either of a vehicle or of water, and you want to know the amount of water in the tank. So if you had a capacitor near the tank, like the fuel gauge of the vehicle. So if you have these coaxial cylinders, and these coaxial cylinders are representative of your capacitor. So you have this inner cylinder, outer cylinder, and then you are having part of the fuel feeding up part of this. So that means that whenever you put fuel, there is a calibration that once the fuel is full, also this small capacitor is full. Once you start draining it as you drive, then also this small one start reducing. So the capacitance is changing because the fuel in here, if the fuel, for example, is at this level, that means the capacitance here, which is having the fuel, there is a capacitance here where the fuel is, and then there is a capacitance here of the empty part. Now when the fuel increases, that capacitance, that will change the capacitance. That's why you see a fuel gauge going, and when they have put fuel and you have started and driven a short while, then it goes to full, if you have filled up the tank. And then it keeps going down, but it's not linear. It is not that you see it going. That non-linearity is because of taking care of these other parameters within a capacitor. But to make a good instrument, you must make sure that at the end of the day you get some output from this instrument in form of either DC current or DC voltage. Either of the two. If you have a DC current, you get a voltage using the resistance in between. So you have the current times the resistance, you get the voltage. You have the voltage divided by the resistance, you get the current. So it's up to you to choose what you want. So I will stop at these displacement whatever, much as I could have quickly finished these bits. And then after the test, I will have confirmed now the real people that are taking this course. If you don't do my test, then the course, you can't take my course if you can't do test one. That's why now in the electromagnetism I know who is in my course officially. All of you at least are there. All of you who were coming for lectures attended the test. So after this test, then I will confirm that these are my students. And then we shall roll. But we are somewhere fairly halfway. Because the bits of modulation, frequency modulation, amplitude modulation, some of those of the amplitude modulation are now obsolete. Only that you need to know the basics. But things have changed so drastic that sometimes we can't go further on something that we won't be using at the end of the day. But the basics will help you to do something.
Sir, you were invited on Saturday.
Yes, I have an invitation letter.
Yes, you should come Saturday to do some Sunday viewing.
I have promised that I will come. I never leave home on Saturdays. But if I get sleepy, I will just say apologies. I will send a message on the wedding. But I would love to come and see how you people are promising to change how you are promising to change the face of physics. So I have an invitation letter, and they told me there are snacks, so I also want to eat your snacks before you eat mine in the future. Okay, so I should say see you on Saturday.
Yes.
I've told you the principle.
You told me not that I come in a short. That it is Saturday, that I come in a short. So I'll come in a short. You see my legs, they are big. Hey, Hutch, I will come in a short, you see my legs very big.